Taking on a greenhouse, high tunnel, or hoop house build can be a large, stressful undertaking. And like with any big project, when mistakes are made, they can be costly, not only in the price it costs to correct the mistake, but also in the labor required to take that corrective action. So in today's video, I'm going to cover the most commonly made greenhouse, high tunnel, and hoop house mistakes so you can avoid them. And you're going to want to watch to the end of this video because if it can help you prevent even making just one mistake, it could save you tons of time and money. So let's get into it. There are 5 main categories that I've found mistakes for high tunnels falling into. The pre-design phase. You're just kind of thinking of high tunnels for your property, for your farm. The design phase. What components and features do you want in your high tunnel? The pre-build phase, you're looking at site preparation, that kind of stuff. The build phase itself, that's a fun one. Tons of mistakes can be made. I've made tons of mistakes in my learning process through the last 15 years. And then the growing phase. Once the structure's been built and you're planting in it, obviously mistakes can be made on that end. I also, I farmed for 5 years. I had high tunnels. I made some growing mistakes as well. So these are the 5 categories where mistakes usually fall into, and we're going to go through these one at a time. And as we go through them, we're just going to cross them off. In most high tunnel paths, there's a tale of 2 routes. You can buy a DIY kit or you can self-fabricate, the true self-fabrication, which I'm considering someone who is trying to make bows on their own. They're trying to figure out how deep anchors should go. They're trying to configure the structure completely on their own. So these are the tale of 2 routes. One is a DIY kit route. You get, a prefabricated metallic structure like the ones we sell at Tunnel Vision Hoops. It comes with instructions and a variety of standard packages are available. With the self-fabrication route, maybe you're someone who has bought a bender from a company that sells a bow bender. Buy a bender, mount it to something, bend some hoops, you're off and running. Both of these routes obviously can result in structures that work, and both of these routes have mistakes associated with them. And I'm going to try to cover mistakes that kind of are made by both. And some of those mistakes overlap, some of them are different, but that's how we're going to take it on. So first, high tunnels are a solution to problems. That's what a high tunnel should be. If you need to extend your CSA, a high tunnel, an unheated high tunnel, might be the solution to that problem. You can get a couple extra weeks at the tail end of the season growing in that high tunnel. That is a solution to a specific problem. You need to start seeds, no problem. A heated high tunnel is a solution to this problem. This is a structure I built in Southern Ohio. There's an awesome heater in there, awesome ventilation system. This high tunnel was a solution to a specific problem. Need a covered wash pack station? A high tunnel can be a solution to that problem. This is a picture from 10 Mothers Farm in North Carolina. Gordon down there was nice enough to give me permission to use this picture in this presentation. But this is an example. There was a problem. They needed a covered wash pack station. The high tunnel was a solution to that problem. In short, the reason I'm bringing this up is this is kind of the first pre-design mistake that's made is people don't have an identified problem and they want to get a high tunnel and just hope that they find a purpose for it. Typically I get a call and someone says, hey, the NRCS EQIP program is doing a reimbursement program for these structures. I don't know what the heck I'm going to use it for, but can you quote me on a structure? I'll figure it out. Of course, I'll quote a structure. That's what we do here at Tunnel Vision Hoops. But the reason I'm saying this could be a mistake is if a high tunnel isn't being purchased to solve a specific problem, a high tunnel can become a burden. It can become that problem in a sense because there's different labor inputs required. You may not have systems set up to deal with what's going on inside of a high tunnel. It doesn't rain in there, so you're going to need to have irrigation set up. It also is a piece of infrastructure, and infrastructure over time requires material investment. So for example, you will need to replace greenhouse plastic on a high tunnel sometime in the future. And additionally, there can be unexpected labor inputs and material inputs. If a branch flies through the plastic and you need to replace it, or something's wonky with the roll-up side because it was installed less than optimally. These are things that if you don't have a problem that the high tunnel is solving, it can become a burden. Luckily, these structures have tons of purposes. So most people who go that route end up finding a purpose for them. If you are having troubles identifying problems that a high tunnel can solve for, reading some of the great books out there, like Elliot Coleman's books, the Winter Harvest Handbook, some of these books will help people identify problems that can be solved with high tunnels. And additionally, I just recommend, becoming more in tune with how high tunnels are installed. So just take a deep dive, go down a YouTube rabbit hole. This is just a screenshot of some of the videos on our YouTube channel. Learn about the construction process, read books on high tunnels. You'll probably find plenty of problems that can be solved with high tunnels. The next mistake, the next pre-design mistake is permit assumptions. And I've seen this happen so many times, and it can be a very costly mistake. And we're just going to kind of go through what this might look like step by step. So for example, I'm in Ohio. My state has an agricultural exemption. Great. I don't have to get permits for agricultural structures. I don't need a permit. That's the assumption. So I buy a kit. It's my dream kit. I get it spec'd out. I have it shipped. And oh man, I have a great time with my friends. We build it. And now we're planting in this structure, and I'm about to harvest some wonderful crops for our first winter CSA. And then the city finds out that I built this high tunnel. That may not be a huge deal, but it also might. I made an assumption we don't need a permit. We do have an agricultural exemption. And then there's two routes, really. I can be lucky or I can be unlucky, depending on what municipality I'm in. So if you're lucky, this is kind of what it looks like. Maybe you don't need a permit. You were right. No big deal. The city finds out. They don't even really care. Or maybe they tell you, hey, you only need a permit and you don't even need engineered stamped drawings. You just draw out where your high tunnel is going to go, do the to scale setback requirements for fences and existing structures, submit that. We'll sign off on it. No big deal. Boy, that was lucky. If you're unlucky and you've gone down this path, this is what that would look like. You may have found out that you weren't even allowed to have an accessory structure on your property. Some places limit the accessory structure size to intentionally prevent people from getting structures like high tunnels, greenhouses, large sheds, outbuildings, in which case there might be negative implications if you've already built a structure. Because some people like to ask for forgiveness and say, hey, I don't want to ask for permission. I want to ask for forgiveness. It's great until you're not forgiven. So this is one example. You may not be allowed to have accessory structures, or maybe the city will say you need a permit and you need to have stamped drawings. What that means is, and this is an example of a set of stamped drawings we had made for a client. That means you'll need to work with the high tunnel manufacturer. You'll need to work with an engineer. You might need more materials depending on your wind and snow load for your municipality. And it does change. Wind and snow loads do change depending on what municipality you're in, depending on the usage of the building and the zoning of the property you're on. Sometimes there's even seismic loads depending on where you're located. We've done an engineer's drawing where we're like, oh, wind and snow. And they're like, oh yeah, but we got to design for this seismic load because it's close to, where, earthquakes happen. And it's like, oh, I didn't even think of that. And this will cost more money. And the reason I'm bringing this up is because if you want to ask for forgiveness, we're all adults here, that's fine. But what I'm saying is, if you go the route of asking for forgiveness and you're not forgiven after the fact, it is much more costly to get stamped drawings, to be sent additional material if you need additional material, to retrofit a structure that's already standing, to include that additional material, and to have a municipality sign off on it. I've seen, people threatened if they don't disassemble their structure, with daily fines. It all depends on the municipality. It sometimes depends on a single gatekeeper, one person inside the building and planning department. So if you have the option, find out if you need a permit beforehand. It could save you a lot of time and money. And also, before I continue, since we're doing self-fabricators versus DIY kits, if you're a self-fabricator and you want to ask for forgiveness and you go ahead and you build it and your city finds out you built something, they will still ask for stamped engineered drawings potentially. That wouldn't change whether it's DIY or self-fabricated. So then you would have to find the specs for all the product that you use to make your structure, find an engineer to trust you and take you seriously, and then work with you as an individual to develop a structure that meets wind and snow load that you can then modify for your site. So that's how it would look if you both, did a DIY kit or, where you self-fabricated. This is an example before I get off the whole engineering, ask about permits and stuff. This is an example of an engineered structure that we did for a client. This is large diameter steel tubing for the bows, but they're 3-foot bow spaced. There's 2 layers of truss rafters. One of the truss rafters goes the full 30-foot width of the structure. This structure has 8-foot sidewalls. There are multiple purlins, more purlins than would be typical with a structure this size. And also, after talking to the contractor, they dumped over 100,000 pounds of concrete for this structure. And that's not a pad. That's just being used in the piers for the anchors around the perimeter of the structure. That's per spec, what the engineer outlined in order to meet wind and snow loads for this specific structure in this municipality. But this just gives you an example of how crazy some of these structures will end up being designed for in order to meet wind and snow loads in certain municipalities. Those are the main pre-design phase mistakes I see people falling into, costly or otherwise. Let's get into the design phase. So by design, I'm referring into the process of determining the setup, the features, the components that a structure will have. And we're going to separate this into, a list of two. So self-fabricators and DIY kits. So the design mistakes that many self-fabricators make. And again, all of these are my personal opinions based on evidence. So if you have a structure that has any of these design elements and it's working for you, I'm super happy for you. I'm going to list, kind of my opinions on design mistakes for these and why I feel that way. But if you have a structure like this, I'm happy for you as long as it's working. So using PVC tubing, I see this a lot on YouTube. I actually get a lot of calls for people who need material for structures that are fabricated out of PVC tubing. The reason this is a mistake, in my personal opinion, is PVC does not react well with greenhouse plastic, but it also doesn't, it's also more difficult to firmly install fasteners into PVC tubing. So screws, bolts, will they strip or, break over time? Will the bolts make the PVC tubing crack in a year or two? And then additionally, PVC tubing, there's various outer diameters, there's various strengths, but they don't all configure well with fittings and hardware that are used to make the other components for structures. How are you going to attach the truss rafters, the hip rail baseboard? How are you going to make your end walls on this structure? So the brace bands, all the cross connectors, those things may not configure as well with PVC tubing. And this is kind of the same case for people who use whatever metal tubing is laying around. I get calls from people who are making high tunnels out of plumber's tubing, electrical, mechanical tubing, which, is doable, of course, and old playground sets. People who call me and they say, hey, I have a swing set laying around. I want to make it into a high tunnel. That is awesome. That is great. I'm on board with people making their own stuff and doing so cheaply and inexpensively. Just know that if you go that route, even though you're using metal, like I said, the hardware in the greenhouse industry, in the high tunnel industry, is primarily built around 1 3/8 inch outer diameter tube, 1 5 inch outer diameter tube, 2 inch outer diameter tube, and to a lesser extent, 2 3/8 inch outer diameter tube, although those are less prevalent. So those may not configure, the hardware may not configure well with plumber's tubing, EMT, or old playground sets. This is just another example here of a mistake that I see self-fabricators make. They saw a video on YouTube, how to make a $500 greenhouse. They make that $500 greenhouse, no problem. And then they want to deck it out with auto roll-up sides, an awesome greenhouse plastic covering, a really nice double sliding door or single sliding, expensive door. I've even had people want solar wrap greenhouse plastic put on a structure that was very inexpensively made. And solar wrap greenhouse plastic, if you're not familiar, it's a very costly greenhouse cover. It costs as much to replace your actual roof on your house. It's very common for me to quote them out, solar wrap greenhouse plastic, where it costs $5,000 to $10,000 to cover a structure. So I've quoted this for structures that were designed very, cheaply and made out of inexpensive materials. The reason this is a mistake is even though you have, let's say, $500 into the structure framing, you might dump a $7,000 greenhouse cover on this structure. If the structure collapses, you're now out the $7,000. So what I would love to see is self-fabricators, instead of, making a $500 greenhouse that is kind of not that strong, take that money that you would invest in the other awesome product and put it into a better frame, make a stronger frame structure. And then you can deal with, the additional awesome add-on benefits, and it won't be as much of a liability. Because I have seen people who have self-fabricated inexpensive structures, they've failed in snow, and then other things that were expensive were lost when they were on that structure. Ignoring advice from professionals. This is kind of a double-edged sword because I like when people take risks, self-fabricators take risks, because sometimes they find really cool things that the industry takes on as a whole. That's very rare, but there are reasons certain things are done. For example, there's a reason when you have roll-up sides that you have a hip rail and a baseboard. If you want to not do a hip rail and have roll-up sides, knock yourself out, but realize there's probably a reason why the industry does that. That's kind of a mistake I see self-fabricators make. Design mistakes that might happen in DIY kits. So one thing that I see happen a lot, beginning farmers who they may not even have broke ground on their property yet, and they want to buy the most complicated structure possible. For example, we sell mobile high tunnel kits here at Tunnel Vision Hoops. They're more costly per square foot. They have custom welding, side entrance doors, that kind of thing. If you haven't broke ground on your farm yet and you've never grown in a high tunnel, it might be a large jump to go from something that's a stationary high tunnel, on the horizon that's kind of basic, to a mobile high tunnel that requires, there's totally different labor inputs, it has to work within your larger farm system. And this, it's not necessarily always a bad thing. Some people figure it out, but just for example, I have sold more expensive mobile tunnels to people who have never moved them, years later. And what that has turned into, it's just a more expensive stationary tunnel. So that's just, one potential mistake. On the other side of that, people who have in the design of their structure configuration gone with the most streamlined DIY kit they possibly can to make it as inexpensive as possible. And the reason that this is a mistake potentially is the less you have in a DIY kit, the more you have to figure out on your own. So the way this looks is, let's say there's a standard full package. It's an all metal package. You get it delivered to you, all the steps for all the processes are outlined there for you. It's got a base level of design elements that you need. And then, as you're looking at this, you're like, well, I could probably design end walls myself out of lumber. No problem. I'll remove the, metal end wall packages. That reduces the price a little bit. I'll go with lumber baseboards instead of metal ones. That reduces the price a little bit. I'm not going to do a door. I'm going to make my own door out of something. I think I saw a door down the street. I'm going to pick it up out of the trash, bring it in and salvage it. Okay. So as you keep removing these items, the cost of the high tunnel kit, the product goes down, but so does the quality. And in some of these elements, strength is compromised. Some people end up removing more and more and more, and to the point where the structure is not as strong. So I see that as a mistake, but also bare bone structures, if you have zero building experience, are even more difficult. It's going to be more difficult to design your own lumber end walls, make your own door, configure a door you're salvaging with an end wall you're designing, anchor that end wall and get it done. It's possible, but what I'm getting at is it's more difficult if you have zero building experience. This one's a personal opinion. I've seen a bunch of these out there, but end walls covered with plywood. I get it. Plywood is solid and it's firm and it creates, kind of like a hard end wall. It doesn't move around in the wind as much as plastic covered end wall would, unless you're getting like polycarbonate. But the reason I don't like plywood covered end walls is over time with rain and water, the freezing and thawing, it gets wavy. And then over time it breaks down and it comes away from the screws that are holding it to framing. I've seen it, get to the point where wind can get inside the structure, which is never good. And that's why I'm not a fan of that. Additionally, one other design component that people have done is they want to save a couple $100, get rid of the spring wire channel. That's fine. If you do that though, one of the alternatives is battening the plastic with furring strips. So they'll take the plastic and they take a furring strip that's lumber, they roll the plastic in it, push it against another piece of lumber, and then they drive screws through it all, basically screws through the lumber furring strip into the lumber behind it, and they're sandwiching the plastic behind it to hold it in place. The reason I don't like that and think it's a mistake is if you need to move your plastic or readjust anything, you now have a ton of holes in some sections of your plastic where the screws went through. Additionally, I think it's easier to add a second layer of plastic if you ever wanted to do an inflation system. And that's why I think that this form of plastic attachment is a mistake. And then the last thing here, people purchasing Caterpillar tunnels only to find out they actually wanted a high tunnel. I get a ton of people like this. We sell Caterpillar tunnels at Tunnel Vision Hoops, so I'm not knocking Caterpillar tunnels as a whole. There's a time and place for them. However, Caterpillar tunnels are designed across the industry to be the lowest cost, most rudimentary version of a season extension structure possible. That's the intent of a Caterpillar tunnel, to lower the per square foot investment cost that people make. So oftentimes when they purchase a Caterpillar tunnel and then later want to convert it into a high tunnel, they're now putting, roll up sides, sometimes metal end wall packages, sometimes a door on these Caterpillar tunnels, which now, because Caterpillar tunnels are designed to be inexpensive, they're often made out of smaller diameter steel tubing, lighter gauge steel tubing. In some cases, they are 5 foot or 6 foot bow spacing instead of 4 foot bow spacing. So now, instead of having a high tunnel that's made out of like large diameter, heavy gauge tubing, which is stronger, it's now it's kind of like a poorly made high tunnel. It's a high tunnel made out of, or I don't want to say poorly made because it can still be well made. It is a high tunnel that's less strong because now you have all of these different elements on top of a structure that might have smaller diameter tubing and larger bow spacing. So that's why I think that might be a mistake, is because essentially if the decisions are made early on to get a high tunnel, if you were to factor the price of a Caterpillar tunnel and all the add-ons, it's probably very similar in price to an actual high tunnel, depending on the size. But I get it. Sometimes people need to, go step by step, get the Caterpillar tunnel first because it's a lower cost thing. And then it just, by the nature of business, eventually they could, invest in what was required for a high tunnel. So I do get that. Again, these are just some things I find out that people regret. Now we're in the pre-build phase. We got the design set up and we're pre-build. Things you need to consider. You need sun. Everyone knows that, right? It doesn't matter. People put these things where they don't get as much sun as they need, and that can be a mistake overall for the things growing inside. This structure location here, as you can see, very, very sunny. The trees to the east there are really far from where these high tunnels actually ended up being installed. This was a great location sun-wise. Drainage, this goes for both inside and outside the structure. So this picture here, this shows inside the structure, there are raised beds. That helps, you know, for the crops growing in there, but also a lot of water runs off the sides of these structures, and it can seep within the structure. You know, it comes down the sides, and then over, you know, the course of a number of hours for a rainstorm, that water can make its way in. When that happens, it can be quite bad. So there are solutions. You can, you know, find a new site for your high tunnel, or for example, here, I think they put a French drain in along the side of the high tunnel and just kind of had that go downhill, and then off, you know, from the end wall itself, about 15 feet away, it just shot downhill even further. So good sunny location, good drainage, those things are primary. And then proximity. Where is this going on your property? How will the high tunnel work within the larger operation of your farm? Is it close to driveways? Will it be easy to get soil in and produce out? You know, maybe you don't want electricity now, but what if you do in the future? You know, for example, in this picture here, it looks like they're running some electrical to this structure. How much would it cost if you were to have electrical run to the structure? Is it closer to where the electrical will tie in? Is it further? How far you are from that kind of stuff will have large implications for the future costs of the structure if you are going to run, you know, different utilities out there at a later date. So thinking about these things now is very important. This picture here is just really to show they did a good job thinking about how these high tunnels would fit into the site that they were building on. They had these large access doors, very good for bringing in soil, very good for taking out produce. You know, they butt up to a small road, and that road hit a larger gravel road. So it was like very quick and easy to get in there. And I just, you know, wanted to include this picture to kind of show what that might look like to have proximity taking into consideration in your operation. Site preparation, of course. If you're going to do site prep, this is the moment to do it. We're pre-built right now. These structures can be very versatile in the way they're installed. There's, you know, a high tunnel on level ground here and a high tunnel on unlevel ground. Your site doesn't necessarily need to be perfectly level. This is not a long enough presentation for me to describe how you navigate installing a high tunnel on unlevel earth, but it is technically possible. I'm bringing this up now though, because this is the point of the process where you would either grade your site to be level, or you'd have a plan of attack for how you're going to do the anchoring of your structure on unlevel earth. So that can help you avoid a mistake. Both are workable, but you need to decide at this point. That's the pre-build phase. Now it's time for the build phase. Everyone has fun building, and we're going to kind of go through a number of pictures where I can talk about common mistakes. Each picture relates to a mistake that people make. These are the most common mistakes I see people making when building a high tunnel. The first thing, there's a build this Saturday. We're building our high tunnel. There are a couple options here. Which one of these is the correct option? I'm going to build it myself. I've been doing this 15 years. I'm going to build this high tunnel. No big deal. I don't want to have to deal with managing people. All my friends, you know, they can't build anything. Or I got 25 friends. I'm going to have pizza. I'm going to have donuts. They're going to come out on Saturday. We're going to knock it out. Which one of these is the right route? In my personal opinion, the answer is neither. You could build them on your own. It takes longer. It's not as fun. Why torture yourself? The same with 25 plus people. The reason I think it's also not the correct route is the high tunnels are installed very sequentially. And sometimes if you have that many people, they all want to do something right away. And they'll invariably, they will do something before they should. They'll probably do it poorly, and you'll likely have to go back and fix it. So in my personal opinion, the right number of people to have for a high tunnel build, 2 can work. But for most people, especially if, you know, they've not built high tunnels before, 4 is a very manageable number. You can split off into teams of 2, you know, get 2 people on a hip rail, 2 people on the baseboard, 2 people on one end wall, 2 people on the other end wall. It just makes for a fast moving and efficient project, and you can do things sequentially without stepping on each other's toes. Barn raisings can be fun, but if they're not organized very, very well, I've seen them get out of control and a lot of redo work is required. The next biggest mistake, squaring a structure. When you're running strings for a high tunnel project, it's one of the most important times for the entire project. It's not that glamorous. It takes a long time sometimes. This will determine whether you have a structure whose footprint is rectangular or a rhombus. It also will determine at later steps how difficult it is to put on purlins or hip rails. If you're really off square and you've really racked your structure, it may result in a situation where your greenhouse plastic just barely fits, or if you're really off square, it doesn't fit. So it's very important to be square. Another mistake I've seen made a number of times is, as you can see in this picture here, we're anchoring some ground posts on a specific side of the string. The mistake I'm referring to here is structures, for example, let's say it's a 30-foot wide structure. That means the ground posts should be 30 feet apart from each other. Now, the way we do it at Tunnel Vision Hoops is 30 feet on center. From center of ground post to center of other ground posts across the width, it's 30 feet. If one of the sides of the ground posts are anchored on the incorrect side of the string, you now do not have an exact 30 feet on center. So it's either 1 inch longer or wider, for example, or 1 inch narrower. So you have a 30-foot and 1 inch wide structure. Doesn't sound like a big deal, but you will actually notice, the bottoms of those bows either pinched in or pinched out if you're off in this manner. Will it impact the structure detrimentally as far as its ability to shed snow or deflect wind? Maybe not, but you will notice this issue. If I was making that mistake, I probably would redo an entire side, but I like to torture myself. You may not have to, but this is a mistake I see happen. Another mistake is the ground posts have to be anchored level, so their tops are level from side to side. If you follow the earth, if it's unlevel and you anchor them to spec, it's not level from side to side, your ground's not level from side to side, you won't have anchors that are level from side to side, which will create a high tunnel whose peak is not shooting straight up towards the sky, it's cocked at an angle, and that could be bad. The hoops are designed to be pointing straight up towards the sky, and you don't want snow building up or landing on part of the structure that's not really the peak. But this is also detrimental in a sense because your truss rafters are installed symmetrically on your structure, and if you install them on a structure that is where the bows are not themselves pointing straight up, the trusses will not be level. If you're going to run trellising, depending on how you do it, it might have impacts negatively on the trellising, but also this will have some impacts on how well it deflects wind and snow because trusses are designed in a certain way to absorb energy, to absorb weight. And if you don't have a structure pointing straight up towards the sky, you're not following that design path. Another problem here, we're just kind of going, as you can see, we're getting closer and closer through the build process all the way to installing the plastic. At this point, this is a mistake I often see people make at the hoop assembly. A lot of manufacturers, us included, our bows will be wider than the structure is. So the bows are, before you take tension off of them, they're like 33 feet for a 30-foot structure, for example. So they're 3 feet wider at the base until you bring them in, mount them in the ground posts. The mistake I see people make is they put the truss rafters on the bow while they're assembling the bow. That's not the mistake. The mistake is they do that and they do not take tension off of the bottom of the bows to make it 30 feet on center. That's why I've included this picture. I've circled a strap I'm using to keep the bow's bottom 30 feet on center. This way I can put the truss rafters on at ground level, which is a little easier, and then lift it all up into place. If you don't do this, if you just put the truss rafters on and don't take tension off the bottom of the bow, there will be extreme pressure on those trusses when you put them on and you actually bring the bows in. It will look bad as well. I mean, there may be over the long term some negative implications as far as the ability of those bows to stand up to inclement weather. I don't know exactly what those are. It's just kind of my assumption based on the weird racking that occurs and the odd pressure that occurs when that's done. This is not a common mistake, but I have seen it happen and it's cost money to repair. But essentially, if you're building a high tunnel, the hoops will go into some form of anchor. You need to connect that bow to the ground post. You got to make sure it's either going to be done with Tech screws or bolts or something. In this case, there's 2 Tech screws here. But if you do not do this and you forget, if your sides are rolled up and a big windstorm comes, you have essentially created a really expensive parachute, and it can be quite dangerous. And obviously the results of this mistake can be very detrimental. This is another common mistake. So I'm installing hip rail, but what's most important about this picture is there is a level on the side of the bow. And the reason this is important is because all of the bows, even though they're put into ground posts, which should have been plumbed, they're quite tall. They might be just kind of leaning which way, as they make their way down the structure until you put on the hip rail, at which point you will plumb each bow. I believe this is important because if each bow is plumb, it's working as it's designed, it's pointing straight up towards the sky, and it's more easily able to shed snow, deflect wind. If you do not do this, the mistake is you'll have bows that might be slightly cocked the full length of the structure. If this happens to one bow, okay, probably not a huge deal, but if every single bow in your structure is not plumb, you may have more issues down the line. We're talking about plumb, let's continue that process. So people who do not plumb their end wall studs will visually look off if you don't have studs that are plumb, but additionally, it is a big deal for structural purposes, specifically if you have any kind of door. You want a door and you want that door to function for any period of time, you have to have plumb studs. This goes for swing doors, double sliding doors, single sliding doors. If you're installing, like a steel roll-up door, all of these doors will operate better for the long term if your studs have been installed plumb. Greenhouse plastic, making our way through the build. There's two major mistakes I see people making. The first one, you could have guessed it, installing the plastic on a windy day. If people are trying to rush to beat a deadline, they try to squeeze in installing greenhouse plastic. You might lose your plastic if you do it on a windy day. Doesn't sound bad, but if it does get damaged, replacing that plastic isn't necessarily inexpensive. Can be for smaller structures. But for example, this picture here is, I think, a 30 by 72 high tunnel. If that plastic were to fly off and get stuck on a fence and there's a bunch of holes in it, we need to replace it, it's going to be in the hundreds of dollars. And depending on where that plastic is having to get shipped from and to, shipping can also be quite costly because oftentimes these rolls of plastic end up being large enough where they have to go LTL freight, which means on a pallet, which means it's more costly. The next mistake I see people making, and this is both DIY kits and self-fabricated, is they try to buy a piece of plastic and just put one piece of plastic over the whole structure like a blanket. And so they're trying to tie in the end walls and the top cover all at once. In my opinion, this is a mistake because it makes for a more crinkled, less tight end wall and top cover pull. In my personal opinion, I like when structures are covered with, 3 different primary pieces of plastic. If you're doing standard plastic, one on the end wall, one on the end wall, and then one on the top. I think you can pull them all tighter, make them all look better, and I think it sets you up for a longer lasting plastic over the life of the structure. Finally, we're on the roll-up sides. The biggest mistake I see people making with roll-up sides is they just don't take the time to make any adjustment required at the time of installation. So in this specific picture here, this is a 92-foot long structure. I did that roll-up side myself, and I'm not saying that to brag. I'm saying it to say it wasn't fun. It didn't look as straight as it looks in this picture at first. I would test it, and then if I noticed, it was a little wonky, I'd roll it all the way down. I'd adjust the attachment hardware that I have holding the roll bar to the plastic, trying to make it either give more or less slack to the roll-up side plastic. Then I test it again, and I did this process a few times until I liked the way it rolled up all the way to the hip rail and all the way down. And then I rolled it down and I permanently attached the hardware that was holding the plastic to the roll bar in place, and then the roll-up side was done. But the reason I'm going through this is to say you might have to try it a few times. So you're going to test it a number of times. You will not regret it in 4 years when you've been looking at a nice roll-up side for 4 years. So that's a mistake that I see people make. They just don't spend the time on the roll-up side. Obviously, with the build process specifically, that's the value of a DIY kit. There are instructions, proven order of operations, specific steps to get things done. With self-fabrication, another potential mistake of the build process will be you don't have instructions to follow. And if you had instructions, from another kit or something, it wouldn't match up necessarily with what you've self-fabricated. So that's another potential misstep on that. Now for the growing phase, I'm not going to talk too much about this. I just have, one really little blurb from my own personal experience of making a mistake when growing in one of these high tunnels. But the reason I'm not going to get too far into this is because everyone knows their operation best, and you're going to make some mistakes when you grow in these structures. You have to learn how the structure's microclimate works for your farm and for what you're growing. There are so many variables when growing in these structures. But this here is my first time growing in a high tunnel. This is a 3-inch kale. I planted this in late fall, and it never got bigger than 3 inches. And we were selling we were trying to sell for market, and we couldn't even sell these at market because they never got bigger than this. I think I just ate them as salad, but I planted way too late. I had read all of Elliot Coleman's books. I had referenced, a lot of the literature out there for plant dates for my climate. I still made the mistake, and you might too, and it's okay. I learned from that mistake, and then, this is a picture from one of the following years. As you can see, we improved drastically at planting. This is also a late fall picture here. All of the things that could be planted in start trays were, and then they were transplanted in. Items that could be direct seeded were direct seeded at the right time. We even had some perennial rosemary growing. So you'll make mistakes when growing, but all those mistakes you'll learn from. And hopefully this presentation has helped you avoid wasting time and wasting money. Thank you so much for watching. If you have one of our Tunnel Vision Hoops DIY greenhouse kits, thanks for supporting our small business. If you don't have one of our structures, we'd love to work with you. You can visit us at tunnelvisionhoops.com or this QR code. Thanks for watching.